Hi dear students, in electrostatics the last part in revision session. In this video session we are going to focus very important concepts, particularly capacitors. We know what is capacitor. Capacitor is a charge and energy storing device. Charge and energy storing device. A capacitor will store these two, charge and energy. Whenever you give charge to the capacitor, you know very well the potential will increase. See, in this diagram you can notice this. The two plates are given charges. This plate is given positive charge. By electrostatic induction, this will acquire negative charge. There is an electric field between the two charges and it is represented by the red lines. And this will happen when you connect with this battery. Okay, so normally a capacitor will store charge. When you connect with the battery, the process will continue. The simple electrical circuit is given. This is the capacitor symbol, which is represented as C, which is connected to a battery of potential difference V. So whenever we give charges to the capacitor, its potential difference will increase. So Q is equal to some constant into the corresponding potential difference, and this constant of proportionality is C, which is called the capacitance of the capacitor, and C is equal to Q divided by V, and this ratio is called the capacitance. Charge given to the capacitor, which is divided to the potential difference. So which is a constant. The capacitance is always constant. Whenever normally we have a doubt, when charges increases, potential will increase, but C remains same. C remains same. C will not increase. Okay, so this is very important point. The basic principle of the capacitor is we have to decrease the potential difference so that we can increase the capacitance. That is a basic principle. So here we have the two plates. One is positively charged and another one is negatively charged. Electric field is going from positive plate to negative plate, which is represented by these red lines, which are parallel to each other and equally spaced. So this is uniform electric field. You just keep in mind. So this is what your electric field, and the distance between the two plates is simply we denote as small d. Now what is the capacitance of a capacitor? Particularly for a parallel plate capacitor, we already know that the electric field between the two plates, by Gauss's law application is simply what we know this sigma divided by epsilon naught. This result we already know that. We know that sigma is surface charge density. So sigma is equal to charge divided by A. Therefore, the electric field between the two plates, in the case of parallel plates, we can write it as Q divided by A epsilon naught. Very simple derivation. 3 mark question you can expect this. Now this relation between the electric field and potential difference is E is equal to V divided by D. Therefore, the potential difference V is equal to electric field distance. We know what is the electric field. So V is equal to Q divided by A epsilon naught into D. This is what your potential difference. Now what is capacitance? C equal to Q divided by simple derivation. What is Q? Charge divided by potential difference. Q into D divided by A epsilon 0. So what happens? Q is getting cancelled. Therefore, capacitance of a parallel plate capacitor is epsilon naught A, which is divided by D. Okay. So this is what your capacitance of a parallel plate capacitor. Its capacitance is directly proportional to area of the plate and inversely proportional to the distance between the two plates. So whenever you increase the area of the plate, when area of the plate increases, capacitance will increase. When distance between the plates decreases, then the capacitance once again increases. So in this way you can increase the capacitance by the increase of area of the plate and by decreasing the distance between the two plates. These are the two important factors. Not only that, this epsilon 0, that also very important factor to determine the capacitance of the capacitor. Here we have used air medium. Actually in between we have air medium. Therefore we used this epsilon. Suppose when we use another medium, we know that epsilon equal to epsilon 0 into epsilon r. Epsilon r is normally greater than 1 for any dielectric medium. When you use a dielectric medium, we simply write epsilon a divided by d, keeping other dimensions are constant. Then epsilon r is greater than 1, therefore the corresponding capacitance will increase. Normally the C dash will be greater than C. So suppose if epsilon r equal to 100, then keeping all the dimensions constant, then C dash will be equal to 100 times C. The capacitance can be increased 100 times when we introduce a capacitance, dielectric constants 100, dielectrics of dielectric constant 100. So this is very important question, you just keep in mind. So you go through this because this will be asked in 3 mark question. Then we go for energy stored in capacitor. We have already explained that capacitor will store not only charge, it also saves energy, stores energy. So energy is always related to work, isn't it? Energy is always related to work. So to store the charge, it has to do some work. That is what energy storage. So the work done to store the charge, it can be written as V dq. So when charge is increased from q to dq, okay, this is the q to q prime, that change will be dq. Okay, so corresponding change in corresponding work is from w to w prime, and that is related to dv to keep the potential difference constant. Okay, now w can be written as integral v dq, is very simple. Okay, so what is v? V is equal to q by c by the definition of capacitor, because capacitance of a capacitor C equal to q by v, therefore v is equal to q by c. Therefore w is equal to q divided by c into dq. From charge only is going to change from 0 to the maximum charge, so that you can take 1 by c constant, so you will get q dq, taking the limit 0 to q. Very simple integration. So it is nothing but 1 by c into, what is q dq integral? It is q square divided by 2. So q square divided by 2 is called electrostatic potential energy stored in the capacitor. Epsilon E is equal to q square divided by 2c. Or you can express the same thing. Suppose if you write q is equal to cv, then this same energy can be expressed in terms of 1 by 2 cv square. Now I am going to write down this expression in terms of energy density. We know that capacitance of a parallel plate capacitor is epsilon naught A divided by D. Therefore epsilon E is equal to epsilon q square. What is q square? Okay, epsilon naught square A square divided by D square. That is what your q square into 1 by 2c. 1 by 2c. Okay, actually this is not correct. You just take it out. Okay, so what is the energy of the capacitor is q square by 2c. Okay, so here q square you can take this formula 1 by 2 cv square for calculating the energy difference, energy density 1 by 2 c. C is epsilon naught A divided by D into V square. What is V square? V is nothing but ED, potential difference. V is equal to electric field into distance. So therefore V square means E square into D square, right? So D can be cancelled. So what you are getting, 1 by 2 epsilon naught this A into D into E square. Okay, so this is what your energy. This A into D is nothing but what? A into D is nothing but volume. Area into distance will give you volume. So energy is equal to volume into 1 by 2 epsilon naught E square. So this energy divided by unit volume will give you small epsilon E, and this quantity is called energy density, that is energy per unit volume, which is equal to 1 by 2 epsilon naught E square. So this is very important relation. So if you want to have more energy density, then you have to get more electric field. So energy density is directly proportional to the electric field, which is very important point. You have to note down this. And now the applications. What are the applications we have? Okay, this is very important point. What are the applications of the capacitor? Very important 3 mark question. You can you have to study this question. So first of all, in flash capacitors we are using the particularly in digital cameras, in flash, to take the photograph we have to use the capacitor in that. So whenever we flash, we need a large amount of energy, and that is delivered by this capacitor, which is the first application. And particularly in cardiac arrest, in medical application, cardiac arrest, the heart defibrillator, you might have seen in many films, particularly in Shivaji, in Rajinikanth the movie. In one frame you have seen that. So during the electric shock, Shivaji went to coma stage, and using the heart defibrillator, and he has been recovered to the normal stage. Okay, so அந்த மாதிரி கேஸ்ல we use the capacitors. We need large amount of electrical energy to stimulate the heart to make function, normal function. Then capacitors are used in the ignition system of the automobile engines. Okay, this is also another important application. And to reduce the power fluctuations, particularly in electric power transmission. So these are all the applications of the electro capacitors.